Okay, so this video is going to take you through on how to properly extract the data for rate of force development of previously saved tests on the BTE. Okay, so first thing you're going to go to is you're going to go to patient records. You're going to click on show patient list. It's going to ask you for a password. You're going to type in RS. You're going to find the individual in question. So for today's example, we'll use this gentleman. You're going to say OK, right, when it opens up his information. And you're going to go to review and reports. Here you're going to see the different isometric tests that are saved under the individual's name. For Brian, you can see that there's a number of different days in which he was tested. We're going to select the 10-10 tests, meaning October 10th. Okay, and you can again click the little plus and minus sign there to be able to select the appropriate days. Okay, once you have the selected test, you're going to click on review, which is just down here. Okay, now you're going to see the 4 different graphs. Some of these are going to be rate of force development, and some of them are going to be the actual strength tests. You'll be able to differentiate them because the rate of force development will look like this. They will end only after a 2-second contraction, whereas if we go to the next evaluation, right, you can tell that that's a strength graph because it's all the way across the 5-second duration of hold time. So let's go back to the rate of force development. Here you're gonna bring your cursor to the bottom of the x-axis. X-axis is gonna populate. You're gonna right-click, and it's gonna say properties down here. So you're gonna go to properties. Here it's gonna ask you for number of decimals. You're gonna click 2. So right, it's set at 0. You can click 1, 2, or you can type in the number. Then you're gonna click on apply. And we're going to hit OK. So this is going to allow you to populate the decimals down here. The next thing you're going to do is right-click on the actual graph itself. It's going to you can scroll down to Data Editor. You click on Data Editor, and now this is going to populate the different data on both the Y and the X axis. Okay. Now, this is where it becomes a little bit tricky because you have to look for the best 3 trials. So for example, trial number 3 looks really good, so I'm going to click on it, and I can actually select it. Just disregard that. Alright, so you can select the different trials down here. I selected number 3 because that looked pretty good, and what I need to do is I need to identify where in the where the graph actually starts to accelerate or ascend, right? Because you didn't start right at 0, so it's going to take a little bit of hunting and pecking. But if we see here, it's 0.38, right? So that's pretty darn close to 0. Anything under 1 can be considered the 0 point. So here, we would say that if this is going to be our 0, then we go 1, 2, 3, and 0.08 would be our data point for 0.3 milliseconds. Okay, so we would write down 15.69. Now for our 50 milliseconds, we'd go up to 0.10, right? So we'd add 0.02 because this is, so just to step back, right? So this is our 0.05 is our 0. This is going to be our 30 milliseconds. This is going to be our 50, and then this is going to adding another 5 milliseconds would bring us up to the 0.15, and we would then need to scroll further over in order to get the data points for 150 milliseconds and 200 milliseconds. And so now I've scrolled. Now you can see that if 0.10 was going to be our was going to be our 100 millisecond. Then the 0.15 would be our 150 millisecond, and then 0.2 would be our 200 millisecond. So this is essentially how you would go through and grab the rate of force development data for the 30, 50, 100, 150, and 200 milliseconds. Additionally, what you'll have to do is then you'll be able to have to look through the additional graphs and identify which ones are appropriate or meet the criteria. Remember that we're looking for the best 3. Okay. Now you're going to hit issues like this where this one can't be used because it doesn't start right at 0, right? So this trial would have to be thrown out and could not be used. This one, however, granted there was a little bit of tension prior to, it comes all the way back down to 0, and so you can even click on the graph and it will bring up that data point, right? So again, 0.31 seconds is the point at which he drops back down below that 1.0 Newton meters, and he stays below that up until 0.36. So we would use this as our 0, and we would add 3 milliseconds, which would put us at 0.39, right? And we'd continue on. Okay, so I hope that's helpful. I can talk to you more about it over the phone if needed.